Calomel electrode, understanding its principles and applications by Dr. M. David Raju, Associate Professor. Introduction. What is Calomel electrode? Definition and basic function. And importance in electrochemistry. These are the three aspects I am going to deal. The definition of Calomel electrode, the importance of Calomel electrode in electrochemistry, and what is exactly the Calomel electrode is all about. So let us see origin and its development. Construction of Calomel electrode. Its components includes mercury, we call it as Hg, mercury chloride, the mixture of Hg2Cl2, mercurous chloride. This mixture we are going to take a reference electrolyte solution. This is called reference electrolyte solution. And the diagram of the Calomel electrode is like this. You see that this tube containing KCl solution, this black portion is KCl solution, and the bent side tube is having a full of KCl solution, and the bottom of this tube contains a glass wool plug, and this is a platinum wire. A is a platinum wire, and B is a opening to fill the KCl solution and mercurous chloride and mercury. And the bottom of this U-tube we find a paste of mercury and mercurous chloride, and down here the mercury is filled. So this is the diagram of the Calomel electrode. The operating principles: electrochemical equilibrium takes place between mercurous chloride plus 2 electrons gives 2 mercury plus 2 chloride ions. That is HgCl2 plus 2 electrons gives 2 Hg plus 2 Cl minus. This is an equilibrium. That means mercurous chloride taking the 2 electrons and converting into a charged mercury and a charged chloride ions, and similarly the charged mercury and charged chloride ion both combine together and gives back a neutral mercurous chloride and 2 electrons. This Hg2Cl2 plus 2 electrons gives rise to Hg plus 2 Cl minus. The principle involved in this is a Nernst equation. The Calomel electrode is based on the Nernst equation. So what the Nernst equation says is this: it gives a relationship between the quantity of the metal and the amount of the electricity produced. How much quantity we are taking and how much electricity that we can generate from that substance. So similarly here Hg2Cl2 solid taking the 2 electrons, this Hg2Cl2 is in neutral taking the 2 electrons and giving 2 Hg liquid plus 2 Cl minus chloride ions, and a combination of this Hg liquid state plus 2 Cl minus gives back Hg2Cl2 solid. See, the Nernst equation here is E is equal to E naught minus RT by NF log EQ. E is equal to E naught minus RT by NF log EQ, where E is electrode potential and E naught is the standard electrode potential. The standard electrode potential is around 0.244 volts for saturated Calomel electrode at 25 degrees centigrade. We know that R is a universal gas constant and T is a temperature in Kelvin. N is the number of moles of electrons exchanged, and in this case, two electrons exchange takes place. And F is, we know very well, it is a standard constant called Faraday's constant, and Q is the reaction coefficient depending on the concentration of ClCl. Q is the reaction coefficient. Now, so types of Calomel electrodes. So standard Calomel electrode, which we call it as SCE in the short form, and saturated Calomel electrode SSE, and variations for different applications we see later. So applications in electrochemistry includes reference electrode in potentiometry. It acts as a reference electrode in potentiometry and in pH measurements in laboratory. pH measurements to finding the value of pH value of a given solution, and it acts as a reference electrode in potentiometry. We take a standard electrode as a platinum electrode. We take a platinum electrode as a standard electrode and reference electrode as a Calomel electrode. The advantages and the limitations of this method is advantages: stability and reproducibility. Advantages are stability and reproducibility, and it's easy to use and maintain. Its maintenance is easy and its usage is easy. And the limitations includes toxicity of mercury. Mercury is, we know very well, it is highly toxic material and a highly toxic substance. So that is the disadvantage in using mercury in this electrode. And environmental concerns. We know that because of the toxicity of mercury, it is not advisable to use. Modern alternatives includes it is a alternative reference electrode. Then electrodes like silver chloride, silver rod is dipped in silver chloride solution, and other non-toxic options. In summary of Calomel electrode, the Calomel electrode consists of mercury in contact with a saturated solution of mercury chloride, that is Hg2Cl2, and this is also known as Calomel. The mixture is called as Calomel. And in reference electrode, it serves as a stable reference electrode in electrochemical cells. Reference electrode, it provides a constant potential against electrodes that can be measured, and its standard potential is 0.244 volts at 25 degrees centigrade. And the Nernst equation is the equation E is equal to E naught minus RT by NF log of Q, or log of concentration is used, and it's a temperature sensitivity. The potential of a Calomel electrode is temperature dependent and necessitating adjustments for accurate measurements. And construction variations, it can be constructed in various forms including saturated and low chloride versions depending on the specific applications. Importance of Calomel electrode in current practices. In the calibration standard, it is widely used in laboratories for calibrating other electrodes and in potentiometric measurements, ensuring accuracy and reliability in electrochemical experiments. Its versatility includes applicable in various fields including analytical chemistry, environmental chemistry, and electrochemical sensors and monitoring and environmental monitoring. Its sustainability and reproducibility, it's a stable and reproducible potential, and making it essential for comparative studies and electrochemical analysis. Regulatory compliances includes often used in regulatory environments where precise measurements are required, pharmaceutical and chemical industries. And it has a historical significance, a traditional reference electrode that has paved the way for modern electrochemical research and development. Thank you.